Hello everyone, so I'm going to do the 9.4 lesson today, which is when we start to get into 3D figures. And so before we learn about some new formulas, let's just talk about the names of certain 3D figures that we're going to be seeing. The first one is a prism, and that's defined as a solid with two bases that are congruent and parallel. So we have an example of a prism here, and I'm highlighting the bases just so that we can see that these are the two bases that are congruent and parallel. They have to be the same, and then they also have to be parallel to each other. We can call this one a triangular prism because that's what the bases are. The bases are triangles. There's lots of different types of prisms depending on what shape the bases are. Next, there's a pyramid. Most of us, I think, know what a pyramid is. It's just a solid with one base and faces that meet at a point. So we can highlight the base. It would be this triangle. And then all the sides, we could also call them faces. That's what the definition is referring to. This specific pyramid would be a triangular pyramid because the base is a triangle. Next, we're going to talk about cylinders. That is just a prism with circular bases. So it has two identical bases. So there's two circles. And it's kind of rounded because of those circles. And so a form of a cylinder that most of us are used to seeing is like a cup. Let's look at the next one, which would be a cone. That is really similar to a pyramid, but the base has to be circular. And so you could think of an ice cream cone as an example, a real world example of this one. Next would be a sphere. And a sphere is a little bit different because there's no base technically for a sphere. It's really just there's a circle at the end and on the inside, and then all the points on the sphere are equidistant or are the same distance from the center point. If you need examples of a sphere, just think of like a ball or planets. Those are real world examples of spheres. So in the next couple of problems, we're just going to classify each solid, and we also have to highlight the bases. So number one, I would start by highlighting this, and that is my base, which tells me what type of pyramid this is, because I can tell it's a pyramid. All the sides meet at one point at the top, and because my base is a rectangle, I would call this a rectangular pyramid. And that's it. So number two, you see that I have a base right here, and then all the sides or the rest of the shape meets at this point, which tells me it's a cone. And cones, there's only one type, so I don't need to specify any more. Number three, it seems like I have a base right here and a base right here. Those two bases are congruent, and then they're also parallel to each other, which makes it a prism. And because the bases are triangles, that makes this a triangular prism. Okay, number four looks a little bit odd, but I can see that all the sides are meeting up at a point on the top. And so that means that we have one base down here on the bottom. And this shape on the bottom, if you count the sides, it seems like it has 6 sides. So the base is a hexagon, which means that this is a hexagonal pyramid, which we don't really see that often, but they do exist. Number 5, this one, I just can tell that it has a circle on the top and a circle on the bottom, which means that this is a cylinder. Number 6, I can see that there's a rectangle on the top and a rectangle on the bottom. Those would be the bases, which means that this is a rectangular prism because there's two bases. If there was only one base, then it would be a pyramid. Okay, next is number 7. Um, it, this one, we have a base in the front, which is a trapezoid, and then there's an identical or congruent trapezoid on the back. And so there's two bases, which makes this a prism, and because the base is in the shape of a trapezoid, this would be a trapezoidal prism, which again, we don't really see that much, but it does exist. Number 8, looks like all the sides are meeting up at a point at the top, which should make you think pyramid, and then the shape at the bottom is a square because it says that all those sides are congruent to each other, which we can tell from these little lines. So this is a square pyramid. Number 9, if I notice this one, I can see there's a base here at the top and then an identical base on the bottom. And those shapes are pentagons, which means that this would be a pentagonal prism. Whenever it has two bases that are congruent and parallel, it's a prism. Number 10, all the sides are meeting up at one point at the top. And so this would be our base. Usually the base is on the bottom, but depending on the way that the shape is given to you, it doesn't necessarily have to be on the bottom. But this one is, and that shape is a triangle. So we would call this a triangular pyramid. Okay. Number 11. It looks like I can tell that this shape and this shape are congruent. And so those would be our bases. And there's two identical ones, which makes this a prism. And those are triangles. So this would be a triangular prism. And then the last one, number 12, there's not really a base to it, but we can tell that it's kind of just like a three-dimensional version of a circle, which is also called a sphere. So I'm going to move on to the next page and just try to remember as best as you can these names for these different 3D figures. And we'll start by talking about surface area of 3D shapes. Eventually we'll move on to talking about volume. But what we're talking about when we're talking about surface area is what it sounds like. What is the area of every shape that is on the surface of a 3D figure? And so that means that we basically need to find the area of the rectangle on the top, the rectangle on the back, the rectangle on the side, the rectangle on this side, the rectangle on the front, and then the rectangle on the back. By finding all those areas and adding them together, that gives us the surface area. The good thing is that there's a formula that kind of does a lot of this for us. And so we're just going to apply this formula to each of our rectangular prisms. Cubes would also count as a rectangular prism. A square base creates a cube, and that is technically a rectangular prism too, because a square is technically a rectangle. So let's look at number 1. All we have to do is 2, and then length times width, so 7 times 13, so 7, 13. Then let's put our plus sign. Next is 2 length times height. So I'm going to do this times this, which would mean 7 times 9. And then 2, the last thing is width times height. So I'm going to do 13 times 9. So we're basically multiplying each of the sides together and then multiplying that times 2 and then adding all of that together, because if you think about it, there's 2 of each of these shapes, right? So when you type all that into your calculator, it's really simple. You just type it in exactly how it looks here, and then it'll give you your answer. This is going to come out to 542, and we would label this as feet squared because our units are feet, and surface area is another type of area, so our units have to be squared. Number 2, we would just use that same formula again, and it's pretty straightforward when you think about it because you just take 2 and then take 2 of the numbers. So 5, 16. Then you take 2 again and then take the first number times the other number. So 5 times 10. And then the last thing is multiply your last 2 numbers together. So 10 and 16. And that's how you set it up. So we start to type that into the calculator and then get our answer from that. That comes out to be 580 centimeters squared. So you can think about like what is the length, what is the width, what is the height, and make sure that you plug them in to this formula exactly like that, but you don't have to because regardless of the order that you plug them into the formula, you'll get the same thing because that's the commutative property of addition and multiplication. It doesn't matter the order that you do things in. So I would recommend just kind of thinking about it the way that I just did that last problem. We can practice that again with number 3. We're going to start with a 2, and then let's pick the first two numbers that we see, so 11 and 6. Plus 2, and then let's do the other 2 numbers, so 6, and 1.5. And then we just multiply the 2 numbers that we haven't multiplied together, which would be the 11 and the 1.5. And making sure to put the 2's in front of each of those and the addition symbol in between each of them. When you type that into the calculator, that'll give you your answer, which comes out to be 183 inches squared. So rectangular prisms are pretty nice to work with when we're finding the surface area. We just have to use that formula. When it comes to all other prisms, we have to do a little bit more, and that's because we have to kind of consider the area of our base. And if our base isn't as simple as a rectangle, which that formula for area of a rectangle is just length times width, then we need to kind of adjust the formula by using whatever the area of whatever our shape is. So if our base is a triangle, then we need to use the formula for area of a triangle. If our base is a pentagon, then we're going to need to find out how to find the area of a pentagon. I think all the ones that we'll see today are just going to be either triangular prisms or trapezoidal prisms, which we do know how to find the area of. So basically, here are the steps. First, find the lateral area, which is the area of the non-bases. Then add the area of the bases. So lateral area has its own formula. It's just the height times the perimeter of the base. That's what each of these letters stand for. Whenever we see a capital B, I want you to think of that as area of the base. It doesn't just mean what is the base, like we've been talking about in the past couple lessons. Capital B specifically means area of the base. So let's start on number 4, and we want to identify what these would be first. What is the height of this shape? Well, the height, the way that you can always identify the height is whatever line connects your 2 bases. So since our bases are this triangle and this triangle, the line that connects them is this one. So our height of the shape is 16. So then the perimeter of the base would be 9 plus 12, and then this side measures 15. So we have to add all those sides together. That's how we find perimeter. So 9 plus 12 plus 15, that gives us 36. So now let's focus on finding capital B, because we're going to use that in the formula. That's area of the base. So since our base is a triangle, I want to do 1/2 times base times height. And now we kind of have to think about what is the base of this triangle. Well, remember, the base and the height have to be perpendicular to each other. So the base is 9 and the height is 12. So 1/2 times 9 times 12. When you type that into the calculator, we get 54. Okay, so now we can find the surface area of this prism. I'm going to do height times perimeter, so 16 times 36, and then plus 2 times area of the base. The area of the base is 54. So this all gets plugged into that formula, and we just type that in the calculator and evaluate our answer. That comes out to 684 inches squared, and that would be the surface area of this triangular prism. So it might be a little bit more complicated because you have to identify the base, the height, the perimeter, and then find the area of the base, and then plug all of that into the surface area formula. But at the end of the day, we're just plugging numbers into a formula and then having the calculator do a lot of the work. So I still think this is pretty straightforward. So let's look at number 5. We want to start by finding our height of the prism first. So the height of the prism is whatever line connects our two bases. We have a triangle on the back and a triangle on the front. These triangles are connected by this line, the 3. So that means that our height is 3. Hello. Next, we need to find our perimeter. So our perimeter would come from adding this side plus this side plus this side, which is 10. So 5 plus 10 plus 12. 5 plus 10 plus 12. 5 plus 10 is 15, and then 15 plus 12 would give us 27. So our perimeter is 27. Now we need to focus on finding the area of the base. So the area of the base, we are going to again need to find the area of the triangle by using the formula 1/2 times base times height. And this is when it can get a little bit confusing because area of the base of the triangle is different from base of the prism. When we're talking about the triangle, this could be our base and this could be our height. And so we need to keep that straight and not use the height that we found earlier in the formula that we're using to find the area of the triangle. So 1/2 times 10, or 12 actually, is what that should be. This is 12, and then our height is 4.1. Okay, and then we can just type that into our calculator and find out what that is. So this is 24.6. Then, now we have everything we need to plug into the surface area formula. So surface area is height times perimeter, so 3 times 27, plus 2 times area of the base. The area of the base we found is 24.6, so we plug that in there. Then we can just type all of that into our calculator and find out what the answer is. When we do that, it would be 130.2 kilometers squared. Okay, and then let's look at number 6. So number 6 is still a prism, and depending on what our bases are, will tell us what kind of prism we have. These would be our bases, and that shape is a trapezoid. So we're dealing with a trapezoidal prism, and that means that we're going to have to use the formula for area of a trapezoid at some point. Let's start by finding our height of the prism. Well, remember the height of the prism is the line that connects your two bases. So it could be considered this line, which doesn't really have a measurement to it. It could also be this line or this line. This one does have a measurement. that's 15. So this is, and if you think about that, all of these would measure 15. So our height is 15. Now let's focus on finding our perimeter of the base. So it's going to be 18 plus 20 plus 23 plus 12. So 18 plus 20 plus 23 plus 12. And when you type that all into your calculator, that should give you 73. And now we can focus on finding the area of the base. Well, since the base is a trapezoid, we're going to need to remember what that formula is. It's going to be 1/2 times height, and then parentheses base 1 plus base 2. So this is, again, an opportunity that you have to notice what is the difference between the height of the prism and the height of the trapezoid. The height of the trapezoid is that line that connects our two bases. So this is a base and this is a base of the trapezoid, and then this would be the height of the trapezoid. So I'm going to say 1/2 times 12, and then 23 plus 18, because those are my bases of the trapezoid. So when I type all that into the calculator, I end up with 246. And now I can find the surface area by plugging in everything. So I start with h times p, which would be 15 times 73, plus 2 times area of the base, which is 246. So this, I go ahead and just type into the calculator. It's going to be 1587 feet squared. Okay, so there's a few more examples of all other prisms. Basically a prism that's not a rectangle as a base. Okay, so let's look at those. Number 7 is another trapezoidal prism. This is one of the trapezoids, and then we have another trapezoid in the front. So we're going to try to think of it similar to what we did in the last problem. This could be our height of the prism, because that's the line that connects the two trapezoids. Next, we need to find the perimeter of the base. So that would be like doing 18 plus 13 plus 10. And then this side is, notice how it's congruent to this side. So they're both 13. So 18 plus 13 plus 10 plus 13. That should give us 54. And now we can find that, oops, I should put capital B for area of the base. So because it's a trapezoid, let's do 1/2 times height. The height of the trapezoid is this line, which the measurement for that is right there. It's 12.4. So 1/2 times 12.4, and then parentheses base 1 plus base 2. Our base 1 is 18, and our base 2 is 10. Okay, so let's go ahead and find out what the area of the base is. That comes out to be 173.6. And now we can find the surface area. It's height times perimeter, so 9 times 54. And then plus 2 times area of the base. So 2 parentheses 173.6. And then we can close that parentheses, type that all into the calculator, and find out what the surface area is. This comes out to be 833.2 millimeters squared. Okay, so number 8 is again a triangular prism, and that means that we're going to need to know the perimeter of the base at some point. Let's see if we can find our height. The height is just the line that connects the two triangles, so it would be this one, the 21. To find the perimeter though, you always just have to add up all the sides, and we don't know what this third side of this triangle is in order to find the perimeter. So we're going to have to calculate what that is, and then whatever that is, we add it to the 15 and 8 to get the perimeter. So notice how this is a right triangle, which means that we can find that length using Pythagorean theorem because we have two sides, and that side would be like our hypotenuse of the right triangle. So I'm going to say 15 squared plus 8 squared is equal to x squared. You could type this all into your calculator at once. 15 squared plus 8 squared, that gives you 289, and that's equal to x squared. Then we just square root that. So x is equal to the square root of 289, which is 17. So that means that this side over here measures 17. And to find the perimeter, we would do 15 plus 17 plus 8, which comes out to be 40. Now let's focus on finding the area of the triangle. So 1/2 times base times height. Our base would be 8, and our height of the triangle would be 15. So 1/2 times 8 times 15. That's equal to 60. And then we can find our surface area. So height times perimeter, 21 times 40, plus 2 times area of the base. The area of the base is 60. So 21 times 40 plus 2 times 60 would be our surface area. When we evaluate that, it comes out to 960 inches squared. So that's our surface area of that prism. We can also talk about finding surface area for cylinders. Cylinders have their own formula, and that's because the bases are circles. And so remember the formula for area of a circle required that we knew the radius, and that's going to be the same thing here. We're still going to need to know the radius. The height of the cylinder is whatever line connects the two circles or the two bases. You might need to know the lateral area sometimes. The lateral area is just the area of non-bases. So that would be the area of everything on this part, everything except the two circles. And so that formula is provided. But really, in the directions for number 9, it just says to find the surface area. So we can go ahead and use this formula for now. This lateral area formula is more useful during certain word problems. So let's think about 2 pi r squared. So we would do 2 pi. Our radius is 11, so 11 squared. And then plus 2 pi r h. So 2 pi, our radius is 11, and our height is 26. This is the line that connects the two circles. So all you have to do is type all that into the calculator in one line, and that'll give you the surface area of the cylinder. It's 2557.26 yards squared. Okay, number 10, there's just a little bit more work to this one because they didn't give us the radius. Notice how our circle is on the right, and all of this is 15, which could be like the diameter of that circle. If I just want half of this, that would be 7.5, or half of 15. So I'm going to use that measurement in my formula. The 9 would be my height. So 2 pi 7.5 squared, because that's my radius, plus 2 pi, and then I need RH. So 7.59. And then you can type all that into the calculator and find out what the surface area of the cylinder is. That would be 777.54 meters squared. Okay, and then there's 2 word problems that are basically just going to test how you can apply these formulas to real world problems. So like number 11, it says if the surface area of the box of cereal below is 272 inches squared, find the length of the box. So we know that this is 2 and this is 12. We want to know what would this be. So we basically just need to use the formula for surface area of whatever shape this is. And this shape is a rectangular prism. And rectangular prism has its own formula for surface area. It's 2 times length times width plus 2 times length times height plus 2 times width times height. So we can go ahead and plug in everything that we know. So since we know the surface area is 272, I can plug that in. 2 times, I don't know what the length is, so I'll just leave that, but the width would be 2. Plus 2 times length times the height, which is 12, plus 2 times width times height, which would be 2 and 12. So this now becomes sort of like an algebra problem. I can multiply these two together. So 272 is equal to 4L, because 2 times 2 is 4. I can also multiply these two together. 2 times 12, that would be 24L. And then I can take 2 times 12 times 2, or 4 times 12 is another way to think about that. That would be 48. Then I need to combine some like terms. So this and this go together because they both have an L attached to them. So 4L plus 24L is 28L plus 48. And then we subtract this 48 from the 272. 272 minus 48 is 224. And that's equal to 28L. Then the last step would be to divide that by 28. And that would give us whatever our length is. 224 divided by 28 is 8. And then our units are inches. So this would be our length. Number 12 says that the surface area of the soup can below is 51.84 inches squared. If the diameter of the can is 3 inches, find the height of the can. So all we need to do is use the formula for surface area of a cylinder. So I know that the surface area is 51.84 and 2 pi r squared. Well, the diameter is 3, which means that the radius would be half of 3, which is 1.5. So 1.5 squared. And then plus 2 pi RH. We don't know the height, so I would just leave that. All right, so what I want to do first is simplify all of this and just put that in the calculator. So 51.84 is equal to, when I evaluate that, I get 14.14 plus, and then I have to do this separately because there's the h attached to it. So I'm just going to do 2 pi times 1.5 in my calculator, and that gives me 9.42 h. And I can't really combine those because one has an h and one doesn't. So what I have to do is move this over to the left. So since it's positive, I'm going to do negative 14.14. Then do the subtraction. So 51.84 minus 14.14 would give me 37.7. And that's equal to 9.42 h. And the last thing I need to do to get h by itself is to divide by 9.42. So in our calculator, we just do 37.7 divided by 9.42, and that gives us 4. So the height of this soup can is 4 inches. All right, so that's it for 9.4. Go ahead and complete the homework and the exit ticket, and I'll see you in the next video.